let us solve the long questions. So that the tangent at p x1 y1 on the curve is root x plus root y is equal to root a is given. The answer is given here. So rough diagram. This is a curve. Phi is equal to f of x, and at this particular point p is given. P is x1 y1. So already we know the tangent equation formula. Y minus y1 is equal to m into x minus x1, where m is equal to dy by dx at x1 y1. So to get m value, differentiate the given curve with respect to x both sides. So d of dx of root x plus root y is equal to d of dx of root x. So derivative of root x is 1 by 2 root x. Derivative of root y is 1 by 2 root y into dy by dx. Derivative of constant is 0. So here multiplying both sides with 2, these 2 gets cancels, and dy by dx value 1 by root y dy by dx is equal to minus 1 by root x. Dy by dx is equal to minus root y by root x. Now you know the value of m. M is equal to dy by dx at x1 y1. So this is root y1 by root x1. So m is there already. Point is given x1 y1. So when point and slope are given, equation of the tangent, substitute the given equation y minus y1 is equal to minus root y1 divided by root x1 into x minus x1. Cross multiply, you will get root x1 into y minus root x1 y1 is equal to minus root y1 x plus root y1 x1. Bring this term to this side and this term to this side. You will get root y1 x plus root x1 y is equal to root x1 y1 plus root y1 x1. This to take root x1 y1 common, root x1 and root y1 common, you will get. In this one, if I take root y1 common, again I will get 1 root y1 plus here also if I take root x1 common from that one, I will take root x1 here. So root x1 root y1, then since point lies on the curve, this point lies on the tangent as well as on the curve. Substitute the given point in the curve. From that I will get root x1 plus root y1 is equal to root x. Use this result in the given problem. So here you will get root x1 plus root y1 is equal to root a. Now divide both sides with this particular term, right hand side term. So on division you will get root y1 x divided by root x1 root y1 plus root x1y divided by root x1 root y1 is equal to root. So here root y1 gets cancelled, root x1 cancels. So on simplification, the final answer will be, see, if I take this term to numerator, that will become x1 to the power of minus 1 by 2 into x, plus if I take this term to numerator, y1 to the power of minus 1 by 2y is equal to root a. This is the required answer. This is the important problem. See, this is the question. If the tangent at any point P and the curve equation is given, intersect the coordinate axis in A and B, then show that the length of AB is constant. So this is the curve at particular point P. We are assuming that as x1, y1. A tangent is drawn, and this tangent is intersecting x-axis at A and y-axis at B. Then our aim is to prove AB is equal to some constant. So this is the question. So for that first part, since this point lies on the tangent as well as the curve, so from that I will get x1 to the power of 2 by 3 plus y1 to the power of 2 by 3 is equal to a to the power of 2 by 3. So to find the tangent equation, we know the formula y minus y1 is equal to m into x minus x1, where m is equal to dy by dx at x1. So differentiate this curve both sides with respect to x. From that I will get derivative of x to the power of 2 by 3 plus y to the power of 2 by 3 is equal to derivative of a to the power of 2 by 3. Now derivative of x to the power of 2 by 3 is 2 by 3 into x to the power of 2 by 3 minus 1 plus derivative of y to the power of 2 by 3 is 2 by 3 y to the power of 2 by 3 minus 1 into dy by dx, that is equal to derivative of constant a0. Again here also this 2 by 3 and 2 by 3 gets cancelled. So x to the power of 2 by 3 minus 1 means x to the power of, after simplification I will get this as minus 1 by 3 plus y to the power of minus 1 by 3 into dy by dx is equal to 0. Now y to the power of minus 1 by 3 dy by dx is equal to minus x to the power of minus 1 by 3. So dy by dx is equal to minus x to the power of minus 1 by 3 divided by y to the power of minus 1 by 3. So bring this term to denominator and this term to numerator. Here you will get y power 1 by 3 divided by x power 1 by 3. So finally m is equal to, we know, dy by dx at x1 y1. So from that I will get, here minus symbol is there, minus y1 to the power of 1 by 3 divided by x1 to the power of 1 by 3. Now find the equation of the tangent here. So on substitution, in y minus y1 is equal to m means y1 to the power of 1 by 3 divided by x1 to the power of 1 by 3 into x minus x1. So on cross multiplication you will get x1 to the power of 1 by 3 into y minus y1 x1 to the power of 1 by 3 is equal to, bring this term to within the bracket, from that I will get minus y1 to the power of 1 by 3 into x plus y1 to the power of 1 by 3 into x1. So bring this term to this side and this term to this side. So you will get y1 to the power of 1 by 3 into x plus x1 to the power of 1 by 3 into y. This is equal to y1 to the power of x1 to the power of 1 by 3 plus y1 to the power of 1 by 3 into x1. From this, if I take common, x1 to the power of 1 by 3 into y1 to the power of 1 by 3 common. From y1, if I take y1 to the power of 1 by 3, y1 to the power of 2 by 3 remains. Again, from x1, if I take x1 to the power of 1 by 3 common, here I will get x1 to the power of 2 by 3. Now this is x1 to the power of 1 by 3, y1 to the power of 1 by 3 into, using the concept first relation, this I will get a to the power of 2 by 3. Now divide both sides with this particular term here. From that I will get y1 to the power of 1 by 3 x plus x1 to the power of 1 by 3 y. Dividing both sides with particular this term means, here I will get x1 to the power of 1 by 3 y1 to the power of 1 by 3 into a to the power of 2 by 3. Here also x1 to the power of 1 by 3 y1 to the power of 1 by 3 a to the power of 2 by 3. This is equal to this whole term by that one, means I will get 1 here. Here again y1 to the power of 1 by 3, this will be cancelled. Here x1 to the power of 1 by 3, x1 by to the power of 1 by 3 cancels. Now this is in the form of x by a plus y by b is equal to 1. So this is a x intercept and this is y intercept. If I know these two, so this particular point becomes a comma 0 and this particular point becomes 0 comma b. So since we have to find ab value, ab is equal to, I will get root of a square plus b square. One simplifying, a square means this particular term, means x1 to the power of 2 by 3 into a to the power of 4 by 3 plus b square means y1 to the power of 2 by 3 a to the power of 4 by 3. So again in these two I can take a to the power of 4 by 3 common, a to the power of 4 by 3 common, remaining terms are x1 to the power of 2 by 3 plus y1 to the power of 2 by 3. Again, since the point lies on the curve, this value already we have calculated. This is a to the power of 4 by 3 into a to the power of 2 by 3. ఫైనల్గా సూక్ష్మీకరించినప్పుడు ఈ రెండు ఎల్సిఎం a power m into a power n is a power m plus n. 4 by 3 plus 2 by 3 means 6 by 3. 6 by 3 means here a square. This is finally, this is a. So length of the AB here, this is a, which means this is constant.